So let's take a look at how we can do that. Electron transfer, this concept of electron transfer is when electrons literally are transferred from one species to another across a chemical change. Okay, and we call this type of electron transfer, there's a special name for it. It's called oxidation reduction reactions. Anytime we have an electron transfer, we would consider that type of a chemical change to be an oxidation reduction reaction. And you have probably in high school chemistry looked at different types of reactions before, and just flip down here real quick and see this particular reaction. At a glance, if I were looking at it, I would say, oh, that's a combination reaction, or that's a synthesis reaction, because I'm starting with two things and they're coming together and I'm forming another, which both are true. But in addition to that, this type of reaction, as we'll see, is also classified as an oxidation reduction reaction. Okay, so an oxidation reduction reaction is a chemical change in which there's a transfer of electrons from one species to another. That means from one reactant to another across the chemical change. And the reason why we call this electron transfer reaction oxidation reduction reactions is because a long time ago people decided that the process of the loss of electrons is called oxidation, and the process of the gain of electrons is called reduction. So anytime you have, since matter is conserved, anytime you have one species losing electrons, you're going to have another species gaining electrons. Okay, you can't have half of it. You always have one accompanied with the other. And to remember what is oxidation, what does the word mean? There's this little device, oil rig. Oil is oxidation is loss of electrons, and rig is reduction is gain of electrons. So oil is loss, reduction, or excuse me, oil is loss. Oxidation is loss, oil, and reduction is gain, rig. So that's just a way to remember those terms. But look over here. This is classically what happens in a type of oxidation reduction. In this case, the model is, we're pretending like this is a metal atom and this is a non-metal atom. And you know, metals tend to lose electrons across a chemical change with a non-metal, which would tend to gain electrons. And so what happens is the result of the reaction is the metal, which was not originally charged, ends up with a positive charge, and the non-metal, which originally was not charged, ends up with a negative charge. And so the electron transfer occurs from the metal to the non-metal, and the result is that the non-metal ends up with a negative charge and the metal ends up with a positive charge. We've seen this before when we talked about ionic compounds. For example, the classic sodium plus chlorine gives sodium chloride. The electron is donated from the sodium to form the cation to the chloride to form the anion. So now looking at this reaction, it's easy to see. I could say, oh yes, I can identify this as an oxidation reduction reaction because I know that originally the magnesium starts off with no charge. It's a neutral atom. The oxygen, neutral elemental molecule, starts off with no charge. But in the end, I end up with this compound, and I know because this is in group 2 that it's going to form a cation with a +2 charge. And so I know that that magnesium really has a +2 charge, and the oxygen really in this compound has a -2 charge. And together they make this neutral ionic compound, magnesium oxide. So we can just look at these types of chemical reactions and identify them as oxidation reduction reactions and identify that across the change electrons are being transferred from one species to another.